This is part 3 of set theory. Here we will further do some other properties related to sets, like union of two sets, intersection of two sets, difference of two sets, then what are disjoint sets, Venn diagram, representation of these sets on Venn diagram, then some other properties and Cartesian product of two sets. So I will start with union of two sets. Let we have two sets A and B, then the union of two sets will be denoted by A union B, and A union B will be defined as the collection of all the elements X such that X belongs to A or X belongs to B. Fine. So in case we have A equal to 1, 2, 3, B equals to A, B, C, then A union B will have all the elements X belongs to A. So we will write 1, 2, 3, then or X belongs to B. So we will write all elements of B also, A, B, C. Fine. And okay, further we will do intersection of two sets. What is the meaning of intersection of two sets? Let A and B are two sets, then the intersection of two sets will be denoted by B, and it will be defined as this is the collection of all the elements X such that X belongs to A and X belongs to B. If you have seen these two definitions properly, the only difference in between A union B and A intersection B is we have written here or and here and. So the collection of all the elements where X belongs to A as well as X belongs to B, or in another language I could see that elements which are common to both A as well as B, only those elements will be included into A intersection B. In case A is equal to A, B, C, D, E, F, and B is equal to 1, 2, E, F, then A intersection B will be, this is the collection of all the elements of X which belongs to both set A and B. So E, F are the two elements which belongs to both A as well as B. So intersection will be equal to E, F. Fine. And the next is difference of two sets. Let us take difference of two sets. A and B are two sets, and the difference of two sets will be represented with A minus B, or we can say B minus A, and A minus B can also be written as A by B, and B minus A can also be written as B by A. The term which is down means it is subtracted from the former. Fine. So how we will represent or define this? So the collection of all the elements X where X belongs to A, so X belongs to A but minus B, that means X will not belongs to B, but X does not belongs to B, right? And in the same way, b minus a, if you have understood this definition properly, then you would know that this is a collection of all the elements x such that x belongs to b but x does not belongs to the subtracted one a. So this is about the difference of two sets. Now the next topic is disjoint sets. What are disjoint sets? Let A and B are two sets which are said to be disjoint. When two sets are said to be disjoints, when intersection of two sets A and B is equal to phi, and in that case we will say that those sets A and B are disjoint sets. In other way, what I can say, that if we consider any two elements A and the other is B, then the elements of A and elements of B will have no any common element. There is no any element which we can say as common. So intersection is equal to phi as per the definition. Intersection means common element, so there is no common element. This is equal to phi, so those sets are called as disjoint sets. Fine. And in case the intersection of two elements is not equal to phi, so these are not disjoint sets. If these are not disjoint sets, the sets which are not disjoint sets, those sets are called as intersecting sets. Fine. So any two sets which intersect, those sets are called as those sets have intersection not equal to phi. And I just want to represent all these elements through Venn diagram. And if you guys know how to describe, how to represent sets on Venn diagram, then it will be easy for you to understand all these definitions through Venn diagram. So let we have any two elements, sorry, not two elements, let any two sets A and B. So this is A, this is B. So if we consider all the points, I am considering all the points, that means of A as well as of B, I am considering all the points. So this will be our A union B. Fine. This is A union B. Now next is, if A and B, this is A, this is B, and if we consider only these points, can I call it out of, I will give you options, let it be A union B or A intersection B. So A union B means we need to write all the elements over here. Fine, all the elements. So all the elements we are not considering here, all the elements we are considering only this portion. So this portion is common to A as well as common to B. So A intersection B means common elements we will take from both the sets. So this is the representation of A intersection B. Fine. Again, we had done difference of sets. Let us consider sets A and set A, set B, and now I am considering only this area. I am considering only this area. So this will be called as what? We are subtracting B. We are subtracting complete B. This portion is blocked. We are not considering this portion. This is completely rejected here. Only this portion is accepted. So this is A minus B. We are completely rejecting B. Even those elements of A which were present in B, we are rejecting those elements also. So the left portion of A, which is not present in B, so that is represented here. So this is the representation of A minus B. Fine. Now we will consider Cartesian product of two sets. Let two sets are A and B, then the Cartesian product of two sets will be represented by A cross B. Fine. And how we will define this? A cross B, or the Cartesian product of A and B, is the collection of all the elements A comma B such that A, first element A, belongs to the set A, first set, and the element B, the second element, belongs to the second set B. So this collection, the collection of all the ordered pairs of the form A, B, whereas A belongs to A, former set, and B belongs to B, the letter set, the letter set, and this collection is called as Cartesian product of two sets. Points here. We had done order of a set. If order of A is equal to M and order of B is equal to N, then order of A cross B, as the name represents, we are multiplying, not multiplying, we are just representing it with multiplication. So the order of both the sets is, first is M, second is N, then the order of A cross B will be equal to Mn, means M will be multiplied with N. In case A cross B, so this is first. Second is, if A cross B is equal to 5, means the Cartesian product of two sets is equal to 5, means it is a null set, it is a void set. Then either this is possible if either A is equal to 5 or B is equal to 5. So if any case any set is equal to 5, then only the Cartesian product of two sets will be equal to 5. And one more thing I would like to tell you, that A cross B, the Cartesian product of A cross B will not be equal to B cross A. There are many students who make mistake that A cross B is equal to B cross A. No, A cross B will be written in such form and B cross A will be written in this form. This is a collection of all the elements of ordered pair B, A, such that B belongs to B and A belongs to A. So this will be the Cartesian product of B cross A. And this is all about set theory, and I will further explain about other concepts related to step theory in the next video. Thank you so much for watching.